Hello everyone. Today I'm going to explain you a linear programming problem, how to solve a linear programming problem using simplex method. I have searched a nice problem and backed it up for our learning, and the sum is as follows. This is a maximization sum. That means we have to maximize the profits or the returns or whatever it may be. So this is basically a maximization sum. It is a maximization sum of two variables x and y, and it has three constraints. Three constraints. So let us proceed to the procedure of solving the sum. So first of all, I'm going to take up the maximization function, and I'll start from C, column C. You can start from anywhere or wherever you would like to take up, and I took C as my cell, and there I'm going to explain. There I'm going to put the value of x, that is 3, and the coefficient of y is 2. Let us leave these two cells, and let us assume that they are invisible values of x and y. That means these two invisible values, we are going to find them now using the simplex method and Excel. So this is my objective function. Right now I'm going to enter the subject to constraints. Okay, the coefficient of in the first constraint, the coefficient of x is 2 and y is 1, and in the second constraint, the coefficient of x is 2 and y is 3. Likewise, in third constraint, the coefficient of x is 3 and y is 1. So these are my constraints and my objective function. To find the profit of the problem, first of all we have to take a empty cell. There you type equal to sum product. Okay, this is the function I'm going to use, sum product. So this is a function, predefined function in Excel, which will help us to do the product of two or more columns or the range of the elements. So I took this one. What I want is that now I'm going to do the sum product of the objective function, and the cells which we imagine as a x and y values. That means we are going to predict them, right? So I'm going to do the sum of it. Enter. So this is my sum product of objective function and the future predicted values. And here now I'm going to enter the constraints. For the first constraint, it is less than 18. For second constraint, it is less than 42, and for third constraint, it is less than 24. So these are my limitations or the conditions given in the constraints. So now what I'm going to do is that again I'm going to find the sum product of the future predicted values and the first constraint. Just remember guys, while defining the range of the elements, you have to separate them with commas. So the second one, again I'm doing the same thing. For the second one, sum product of the imaginary row and the second constraint. Enter. And likewise for the third one, equal to sum product and the third constraint. sorry, I'm so sorry. If you didn't give comma, right, the values keep changing like how it happened just right now. So this is my complete data which I need for the simplex procedure. Now I'm proceeding to the simplex procedure. Now I have everything which I required to obtain the simplex to obtain the optimum solution of this linear programming problem. To perform simplex method, first of all we have to go to data, and then we have to select solver. In this solver we have to, first of all we have to take the objective function. Here set objective function. This is our this is our objective function. See, our aim is to maximize the profit, so I adopted maximization of the profit, and you can even adopt minimization if according to your sum by changing the variable cells. See, here I'm going to enter the cells in which I want x and y values. So basically we took C1 and D1 as our imaginary cells or the future predicted cells. So I'm taking C1 and D1 as my variable cells, changing variable cells. Now I'm going to add constraints. So this is my constraints. Cell reference is 0 and the constraint is less than or equal to, and here in the constraint you have to take 18. Okay. Now I'm going to add another constraint, this one, and 42. Yeah. Next I'm going to add another constraint, 0 and 24. So now I'm going to solve this one. See, here you have to put this thing to simplex linear programming problem. Now I'm asking it to solve. It returned me some message. If I click OK, the answer will be displayed. See, this is our objective function column. This is our maximized product. That means to this particular problem, the maximized z is 33, the value of x is 3, and the value of y is 12. So we solve linear programming problem through simplex method using Excel. For the same problem, I would like to calculate the same solution for the linear programming program in the graphical method as well. So let us reconsider this sum and execute it by graphical method. For the graphical method, we need to calculate few more things rather than this. So for the graphical method, we have, first of all, I would like to enter x and y values. Since there are 3 constraints and 2 variables, I would like to enter x and y for 3 times, x and y and x and y. I'm sorry, x comma, yeah. So this x and y is for constraint number 1, and this x and y is for constraint number 2, and this x and y are for constraint number 3. So when in the constraint 1, 2x plus y less than or equal to 18, when x equal to 0, y equal to 18, and when y equal to 0, x equal to 9. And in the constraint 2, when x equal to 0, y equal to 42 divided by 3, that is 14. And when y equal to 0, x equal to 42 by 2, that is 21. And in the third constraint, when x equal to 0, y equal to 24, and when y equal to 0, x equal to 24 by 3, that is 8. So we are ready with our points. So these are our points that we obtained from the constraints and constraints. So now I'm going to build a diagram chart for the a graph for this. So first of all, to build a chart or a diagram, we have to select the cells we want to construct a line. Now we have to click on insert. Now we are going to construct a graph for this. So I have opted for insert, and then I have selected a chart which suits the linear programming problem, and then I selected to click on I clicked on the draw option to draw it. Again, now I'm at and now I was now I'm going to add one more line to this. For that, you have to give a right click and then select data. You have to click on select data, then add. Name is series name. Let's say series 2, and the x values here. These are our x values, and y values here. Okay. See, if you remember, our constraints are less than or equal to constraints, so we'll get a faded area under this line, under the lines. So let us do or let us plot the third constraint also, so that we'll get a clarity. Again, to add a third constraint, I'm saying to add a series, and the series name, let us say that SIRIES series 3, and the values of x are 0 and 8, and the values of y are 24. These are our constraints, and now I completed the constraints. So if you remember our sum, this is a less than or equal to sign, so we'll get a faded area of this part. Wait. So this is our plotted area. This so this is our plotted area we get. So this will be our plotted area, and we'll obtain the feasible solution in this area. And I hope you like this, and thank you.